Hello everyone. In this video we are going to talk about a very important formula in trig called the law of sines. And we are going to prove the law of sines. So what we have here is we have a triangle. Any triangle. It does not need to be a right triangle. It can be a triangle with any angles. And we have the angles denoted alpha, beta, and gamma, these Greek letters. We also have the lengths of the sides opposite these angles labeled A, B, and C using Latin letters. And the law of sines says that if I take the ratio of the sine of the angle divided by the length of the opposite side, that ratio will be the same regardless of what angle I choose. The law of sines can also be written by taking the reciprocals of these ratios as follows. But we'll stick with it this way, with the sine of the angles in the numerator. Now, in order to prove the law of sines, we're going to do something that's maybe not immediately obvious. We're going to think about the area of this triangle. Now, how do you measure the area of a triangle? The area of a triangle is given by 1/2 base times height. So if I were to measure the area of this triangle here, I can see that the base is b. All right, so I'm going to take 1/2 times b times, well, I got to get the height of this triangle. To get the height of the triangle, I will just drop a line from the top vertex here down orthogonally to the edge B. All right? I just have to find the length of this line segment. Well, we know from basic trig that the length of this line segment will be A times the sine of gamma. So now I know how to find the area of this triangle. The area is going to be 1/2 B times the height, which we said was A sine gamma. All right, well, that's one way to compute the area, but there's another way to compute the area because I can spin this triangle around. All right, now that I've spun the triangle around, we see that the base is now represented by C. To find the height, I'll extend a line down from this vertex up here. So I have to somehow find the length of this line segment. Well, we know from basic trig that the length of this is going to be B times the sine of alpha. So another way to express the area would be 1/2 times the base, which is C, times B sine alpha. All right, so we're going to compute the area one final way. We're going to use the angle beta. All right, now if I take the length of this side here, A, and multiply by the sine of beta, I will get the height here. That's another way to find this height. A times the sine of beta. And the base of the triangle is C, so if I multiply the 1/2 C times A sine beta, I will have the area. Okay, so we've expressed the area three different ways. Now what we're going to do is, since these are all equivalent ways of expressing the area, we can set these equal to each other. So I'm going to take the first line and set it equal to the second line. Let's see what we get. Now, when I have this equation, I can divide both sides by 1/2, and I can divide both sides by b. And what I can do now is divide both sides by a and divide both sides by c. And so we have this equation. I can also take the first formula and set it equal to the last formula because they're equal. They're both giving me the area of the triangle. And I can divide both sides by 1/2. I can divide both sides by A. I can divide both sides by B and divide both sides by C. And so we have this relationship. But now we've proven the law of sines. As you can see, sine of gamma over C equals sine of alpha over A. And sine of gamma over C equals sine of beta over B. So that means sine of alpha over A has to also equal sine of beta over B. All of these are equal to each other. That proves the law of sines.